Hey, Science Seekers, this is Mr. Pfeiffer. We are here talking to some of our GSP finalists about their studies. They had to find something they love and make it better with science. Azan, let's talk about your project. I'm going to show everybody your awesome website. Can you tell me exactly what this title means and exactly what it is that you were doing with this experiment?
Yeah. So the title is The Accuracy of the Diagnosis of Brain Tumors through MRI scans using a deep learning convolutional neural network. What this means is I created an AI, in essence, that learns based on itself, analyzing images, in this case, MRI scans, and diagnosing brain tumors, which includes just abnormalities in general, including brain cancers and stuff like that.
When we talk about research, what kind of research went into this? Walk me through what I'm looking at here.
Yeah, so I described and looked at brain tumors and what they are, the implications, and just an overall overview of brain tumors. Then I looked at MRI scans, how radiologists analyze MRI scans, what they are, and how they work. And I looked at artificial intelligence in a nutshell. And I looked at the different subcategories, what it is overall, what a neural network is what my project ran on, and how it works. And you could see that equation down. There's every
Yeah.
neuron has that um, linear regression model.
So this is, what is this image kind of just explaining here? So I start on the left and then it networks its way out.
Yeah, so it starts with some input layers, which just take in the image and process it,
Mhm.
and then it passes through another layer. It passes some of the information, some of the neurons fire and pass on to the next layer, where it gets processed even further, and each of the neurons do its thing. They add its weights, offsets, and everything, and overall it keeps doing that until it gets to the output layer, which it just provides a binary or
Got it.
it just puts in categories.
Okay. So now let's talk about your actual models here. So I thought this was quite intriguing. So you have these different methods. Yours is more of obviously an engineering design and coding type of project. So the scientific method was a little bit different. We talked about that. Can you explain this whole methodology and how this all works a little bit?
Yeah. So my method on the right side, the labeled method, is what I did for this specific project. How I looked at is it possible to diagnose brain tumors? So I first describe how my algorithm, how my program takes in the data and what it does to it, quantify, sanitize, and then categorize, and how the data looks when it's then passed on to the model, and which the model is uh, learns based on that data.
And you have 15 models here. So let's just real quick show like your beginning first model, and then I'll maybe show an end one to see how this evolves as you continue to revise your model. Very engineering-esque of you. So what am I looking at here?
Yeah, so this is my starting model, the model which I built everything on. So it starts off with one convolutional net layer, which is basically a set of filters that is applied to the image, and it basically changes the image in such a way, and then it brings it to the next layer, the max pooling, which basically condenses it, takes the important parts, and then passes it on to a flattened layer, which it then converts right back to numerical raw-ish values, and then it's processed through layers, as I described in my research.
Okay, so we see that, and then if I go down to like your final, you can see there's what's the difference here?
Yeah, so this is my final model, the model that happened to get the best results and the ideal results. My goal with this entire project was get a 95% accuracy and sub-second speeds. What I did, I basically had one big convolutional model, and what I did, I put it to a rather big pooling layer, which then it will be passed on to a convolution layer, and then another small pooling layer, which basically gives it the chance to give really analyze the image and really put its weights to work and everything. That's the description of my code for the technologically inclined.
So when you said code, can you explain what kind of code is this? What am I looking for here?
Yeah, so this is a Python code which is built on the Keras model, and I use TensorFlow as my module to build up the actual program, and that's the entire algorithm.
Okay, and then to
This
see
is the
action. Where's that video of you actually doing it where you did put in a brain scan and then it came back?
Oh yeah, that's in the real world application. This is
The
the
raw.
raw results
Yeah.
in which I get the raw accuracy and the whole progress of my training and testing.
So when I click on this and I see this is you putting it in, I'm gonna let you talk.
Diagnosis. The usage of my models to diagnose brain tumors and putting it in practice. My models, if you recall, are convolutional neural networks that can detect brain tumors with 96% accuracy. Here you can see that I have my
Right down there. Yep.
my system running.
Welcome to
And
Brain
it gives a
Diagnose.
little introduction here. It sets up the AI resources with a log over here. And now it's ready for diagnosing brain tumors.
Okay.
Over here, you could see that I specified the in and out folder, where the in folder is where I feed all the images, and the out folder is where it spits out all the images that are processed.
So ultimately, I'm gonna fast forward a little
Cancer's
bit. So you
Yeah.
put that in there,
and normal MRI scan.
and once it scans it,
Here, now we will be putting it into the in folder, where the system is currently watching and waiting for images to be fed in. Now here you can see that I received it, and it's now going to be giving.
and then it's giving you all the data
Here you can see for the
results.
it seemed to have
Seems to
come in
be a
red,
benign tumor.
and it gave a little description
Wow.
on what a benign tumor is.
Okay, so I guess we need to get to some questions real quick, Azan. All right.
Yeah.
One, how is this innovative and changing the world, making it better with science?
Yeah, so the whole idea of this project is to analyze how AI could be used in healthcare. And I believe that AI could have a positive impact in the world of healthcare. And second opinions in general are very much important in today's world, where one false diagnosis, one miscalculation, something that could be off could cost someone's life. So having a second opinion, or even just one very much accurate first opinion, is very important, very vital in saving lives, helping lives.
What's the one struggle, one success that you had in your journey and process throughout creating this application?
Yeah, so one struggle, as you can imagine, is probably making the model's architecture and getting it down to an art almost of being able to find the right combinations, the right number of neurons, the right sizes for each layer to get some good results, get a model that can successfully diagnose brain tumors accurately and fast. And one success that I made was obviously achieving that, and also creating the system, the real world application, real world system that can process brain tumors and spit them out almost in a realistic environment, where some redesign I could do is have it a native app to an MRI scanner and possibly automatically feed it, and possibly even show how the diagnosis would be made, and more information on it.
This is about all the time we have, Azan, but I want to let you know that this is a serious topic for many of us. I know you and I both personally are dealing with, you've dealt with someone in your family with cancer, and I have a colleague and friend, very good friend of mine that is processing a lot of that right now. So,
Yeah.
the fact that you're doing something for, humanity to that regard at such a young age is very impressive, and you should be very proud of the work that you're helping to do to help our world. So with that, we say goodbye and well done, buddy.
Thank you.